we go, project one. So I'm assuming most of you guys have had a chance to look at the spec, maybe even hopefully have gotten started, but I wanted to give you guys a top-down look at the whole system. So here are some slides you can look at, and maybe you'll find this video useful. So let's just start off by seeing what it's supposed to do. So I'll compile my code, and then I will start up Ordinate UI. All right, so this will take a little while because it has to open these big CSV files. I guess while it's doing that, I'll mention that, well, what it's doing is it's opening whatever files are in this config file, and this right here happens to be quite large. So if you look at this, yeah, 91 megabytes of data that needs to get parsed and stowed in whatever data structures I've chosen. So still going. Okay, now at this point I could say help. I get some somewhat helpful help message here. I can do things like, I want to say, what is the count of the word, I don't know, potato in the year 1966? Okay, 19,101 times it appeared. Great. I want to maybe make plots of data. Or actually, no, let's do hyponyms. So what are the hyponyms of potato? This also includes the synonyms, actually. Okay, so we got all these exciting things. There we go. Irish potato, Slotum. All right. Cool. I don't know. Josh. Oh, okay. Ha. So there you go. So it should never crash. We don't have any rules about what it should say. So if you want to do a more industrial strength thing, maybe you give some better thing than a null pointer exception. So Josh is not in here. You know, I don't know. God. Oh, there's a lot of these. Cool. Mary Magdalene. That's confusing. So we can also use our tool to make graphical plots. For example, let's look at the relative frequency of the word electronic over all time, let's say. So if we open this up, we see a funny thing, which is that apparently the word electronic used to be very popular back in the 1500s, before declining all the way down to where it's no longer that big a deal, and then surging back again after electronics are invented. We can actually plot multiple things on the same history plot. Yes, history plot. So we do this, and we get electronic and airport. And again, strangely, it seems that there's this vague evidence of a pre-industrial civilization that I guess underwent some cataclysm, and then, you know, things got better again. Now, that's not actually what happened, of course. Instead, what it is some of the early volumes here. There's probably only one volume from each of these years, and they're just mislabeled. So whatever volume was accidentally included and was supposedly from the early 1508 period, it must have used the word electronic a lot. Though over here there's tons and tons of volumes, so a single mislabeled volume isn't going to cause these huge spikes. So since we're normalizing data, this is a classic issue that if you're dealing with data, that if you're normalizing against a really small data set, you can end up amplifying noise in very strange ways like this. So what I'd say is data before 1750 ought to be skeptical. There's so little data from those times that normalization enhances artifacts, just not trustworthy. Now looking at more modern times, we see that airport actually has some neat artifacts. Like there's this strange surge here, and then this really big spike somewhere around the 1940s for some reason, before settling back down. And then both of these, you know, climb, and then both seem to drop. So at that point, you know, you might think, is that an artifact of the data? Is that a problem with my program? We can double check our work, actually, by going to the Google Ngrams website. So there's, wrong one. Let's see, this. So I could actually put in airport and electronic. I will then change smoothing to 0, put this as 1500, and then, I don't know, 2050. And we'll just search all the books ever, and we see that. Okay, even Google's official tool for this, yeah, we see the spike in the ancient past about airports and electronics, and we actually also see the dip in their data set. So, you know, we're rebuilding their tool. So I guess you can use this, by the way, as a way to double check if you don't want to write a bunch of JUnit tests. This could be maybe a more efficient way. Okay, so we can actually restrict the range of our queries a little bit. I can, for example, say, I only want to know about the year 1800, let's say, to present. And at this point, I might ask for, I don't know, let's pick some other, let's say horse and computer. Those seem good. We see that, yep, all right. So horse fluctuated a lot in popularity. It was 0.001 of all words, where 1 would be every word's the same. There was a little bit of a dip at some point in the late 1800s. Computers surged up at this point. But what's interesting is that actually horse is making quite a comeback and has actually surpassed computer lately. So I'm not sure what this portends, but it's certainly a trend to keep our eye on. So if you guys, don't make the GPA cutoff, I guess, there's the notion of horse mastery, maybe the next big thing. All right. But I think you'll be good. All right. So if you're with me now and you're watching, we'll get through this and become awesome computer scientists. Okay. But just beware. Plan B. All right. So up next is hypohist. So we can actually ask for not just the history of a particular word, but I could say I want to know about all of those words that have to do with, say, all these God words. So here we're summing every single word that has to do with some kind of God, and we see it fluctuated over time. No big trends here. We can do all kinds of things, like, I don't know, drinks. So this is anything that's a drink. So drinks got less popular in the 20s and now have spiked up again, whatever that means, okay? And I don't know what else you might discover, but it could be cool. All right, now word length, I guess I'm going to hide the results because I don't want to spoil it. So I'm going to say range 1900 to 1910. I could say, what's the word length average? And we'd see that the average word length between 1900 and 1910 barely changed, okay? But I'll leave that as an interesting puzzle you can solve. And as our very last thing, we can make a Zipf's law plot. And I guess we'll just mention, I don't know, we'll do 1850. So if we plot all of the words in 1850, we plot their counts versus their ranks, it looks like this. And I'll leave it to the spec to explain what this all means, but it's a surprising result. Okay, so that's what we want to build. So how are we going to build this system? Well, I've broken out the API for you, so I've done that part. And your job is just to implement the classes, mostly as an exercise in abstract data type implementation, as well as getting a handle on generics and a sense of how one builds a larger system. So here, all these lavender colored classes, these are the ones you're going to write, and I've annotated each one with a number of lines of code that our solution uses. I'm not including the specific classes for JUnit tests, but that's about how many lines I ended up using. Actually slightly more, but some of them were a little silly. And then plotter I have in blue here because we're, as I'll say later, going to give away a lot of this, but you're welcome to do it from scratch if you'd like. And these are 3 classes we provide for you that you might find helpful, and that's the scoop. So this is our top-level interface. This is where we're going to store the data in these 2 classes. This is a utility function for doing the word length thing, and these are some containers, some more classic abstract data types where we can put stuff, all right? Okay, so moving forward then. So there's a recommended order. This is straight out of the spec. I'd suggest you go in this order. I mean, you don't have to. You can write the UE first if you want. But the nice thing about working from the bottom up as opposed to the top down is you avoid the temptation to try and test your class by typing in commands, right? Because I could have, in theory, written all my stuff and then tried to test things from here. And sometimes this seems like a good idea. So I could ask, like, the count of potato again in 1955. I could maybe try and debug my code that way, but I don't recommend it. It's better, I'd say, usually to work bottom up. Not always. So this is the order I recommend, and I do actually intend that you might consider doing this thing. So it goes through generics and just covers some of the weird stuff that happens with method signatures. So you might find it helpful to try and do that. Not required, but I don't know. I don't think it's a bad idea. All right. So let me note that this video, of course, is static. I'll tweak these slides as we go, but I think the top place to go if you have common problems is here. So there's a Piazza thread, which is the common issues with the project. Let's make sure it's the right one. Yeah, so make sure to look here first if you have a common question, and please update as we go. Okay, so now implementing. So I'm actually going to talk from the top down, even though that's not the way I recommend implementing, just because I think it gives a better narrative structure. Okay. So the basic idea is that when I try to start up my UE, it's going to read NordNet, its config file, to find all the files it needs. So if we actually open up that file, so I go into NordNet and I print out NordNet config, these are the 4 files it's going to try and read, and it's assuming that I'm running it from this directory. So in this case, it'll read all of these files, and that will, find all the input files that I need. So it's going to take everything in all words and in total counts, and it's going to cram that data into this ngram map object, and then these 2 things are going to be put inside of WordNet, and the spec goes through all the little details of that. The user will then input commands as we've been doing, which will make calls to plotter, which is then going to make calls to xchart. Okay. All right. So that's the top-down view. Now, working our way down a little bit, we come to WordNet, which is the first class you should write. So, of course, the WordNet database, it is well, maybe you don't know this already if you haven't read it yet, but the WordNet database is a list of hyponym relationships, or is-a relationships. So nice that we spent all that time talking about weird inheritance stuff, because now you have a whole database of relationships you could use to decide if inheritance relationships are a good idea. So every word here is a noun in the WordNet database. So there are no verbs, it's all nouns. And so what you'll do is, this is a very simple one. This is not from the big database. So in this case, it would say action is a change, change is a, or sorry, other way around. We'd say that one type of one type of change is demotion, a demotion, right? So one way that a change can occur is being demoted. So so demotion is a type of change. Change is a type of action, and so forth. Okay, so when you see an arrow, that's what it means. Now, it may be that some words, say jump, actually represents multiple ideas. So one meaning of jump is this notion of, say, jumping out of an airplane or parachuting. See, these are synonyms for the same idea, and we call this thing a synset. It's the set of all words in English that represent one particular idea, roughly, as determined by some linguist somewhere. And here we have another sense of the word jump, which is actually more like leaping or jumping. So they're not quite the same, because they're almost the opposite, right? If you're saying, I'm going to go jump, you're implying in this sense that you're going to go downwards, probably very far, and use a parachute. If you say, I'm going to go jump, and you mean an increase, you would be, well, it'd be weird if you were saying you're going to jump, but this is a notion of like, sales jumped this quarter, they increased, right? So that's the word jump. And of course, there are many possible, I was about to say implementations, but hyponyms of a particular word. Like there are different ways to increase. So you could say there was a jump in sales, or you could say there's an augmentation in sales. And here, just in English, this has slightly different connotations than this one. It's not quite the same kind of increase. Augmentation might imply something that was there before has been made better in a maybe more modular way. I don't know. You have to look it up in the dictionary. And then, of course, some words can actually be two things at once. So Actifed is a thing which is both an antihistamine and a nasal decongestant. Speaking of which, sorry for recording this video while sick. I'll probably be sniffling from time to time, but what can you do? All right, so the primary goal of the WordNet class is specifically to be able to find all words that capture a certain idea, right? So this is from some of the data files, Hyponyms 14 and Synsets 14. Suppose we want to know the hyponyms of change. We're saying we want to find all of the words that someone might use to represent the idea of change. Now, of course, the word change itself might represent many ideas. So change here represents the idea of an alteration or a modification, whereas change here is more of like a, well, I don't know, it's some kind of action, right? And of course, there's a lot of really subtle linguistic distinctions here, and this is things that some linguists, someplace, well, at Princeton, have thought very carefully about. You're not expected to understand all the little details here. Just trust the linguists. All right. So whenever we ask for the hyponyms of change, we're going to start from each of these two places in the graph and walk our way down to the bottom and find everything that matches. So you'll want to use Graph Helper, which I'll say a tiny bit about in a bit. But the idea is that we want to be really careful about making sure we get the exact right stuff, hence these diagrams. So all of these words capture the idea of change. These ones do not, right? You might be initially tempted to say, but Josh, isn't alteration a type of change, and therefore modification, adjustment, conversion, and mutation are change? And I would say no, all right? And the reason is it's just not capturing the sense of this word. Now, unfortunately, the name I chose here, hyponyms, is a little bit deceptive because maybe, hyponyms, you'll see that I've also included the synonyms of this word. So I don't know. Maybe a better name for hyponyms would have been words that capture the idea of. Okay, so maybe you could just remember that. So hyponyms here, just not the best name. All right. Now, it also doesn't include, and this is just another subtlety. So if I look for change, imagine I had a data file where somehow event went straight to transition, which went to flashback, okay? So this is not in your data set, but if it were, if I looked up change, I would not include this sense of transition, all right? Because this is not a type of change. These things are not changes by the linguists who built this database, right? It is true that transition, right, is a word used to describe two different ideas in English, but these ideas are not instances of this word change, okay? So it's a little subtle, but I think that should fully disambiguate it, and if not, well, there'll be another slide after this one. All right, so some various tips. The hyponyms method maybe should have been named something like hyponyms and synonyms, or I don't know, all words that capture the idea. Now in the spec, I tell you to use digraph or graph helper. If you don't want to, that's fine, okay? But I think it'll be easier. It doesn't matter where you put those input files you download, as long as your tests know where to find them. And don't go too crazy trying to write tests, right? So in 61B, you guys should write the tests that feel like they're saving you time. We will look to make sure you guys have vague code coverage, but it may be that, for example, using the Google Ngrams viewer is a better use of your time for doing quick checks. Who knows? All right. Your code should be able to read hyponyms and synsets.txt, the big ones, in less than around 5 seconds. And make sure you check out the demo files for more examples than the ones I've done here. So next up is the Ngram map and supporting classes. And in this case, what we're going to do is we'll be taking data and files which are described in the spec I won't talk about here, using these two classes as special purpose collections. So the goal here is to allow us to make rapid queries to the Ngram map class. For example, I want to know the whole history of the word cake, and I can either ask for absolute counts, like the literal counts, like 88,000, 89,000, etc., or I can ask for the relative frequencies. That is, this word was 0.0001 of all words this year. And we also want to maybe get the process history of the entire data set. So I want to know how long was the average word over time. Okay. So this class right here is going to read in the data files and use these as convenient special purpose collections to store it. So the first collection you guys will write, and this is the next piece you should do after WordNet, is the time series class. Now this is an example of extending a class versus delegating that we talked about in class this week. And the time series class, what it does is it's a special purpose map that always goes from an integer representing a year number, like 1995, to some type of numerical data. That could be a double or an integer or other numerical types. And we'll use it for various purposes throughout the assignment, including, for example, word counts. So if we look at the plot, like one of these plots we made, I mean, this is basically, these are time series right here. All of them actually are, right? So all of these things are time series. This is mapping a year number to some doubles. So the time series, because it extends tree map, it has all tree map methods, but you're going to add 4 more. Well, these are the most crucial things. You also have constructors. So there'll be a plus method that lets you add 2 time series, a divided by method that lets you divide one time series by another. So these are convenient things maps can't do. And then also these funny 2 methods that return a collection of numbers that correspond to the years, right? As well as the data. Okay, so now these are in time series demo, and I really hope you guys have noticed that these exist. But yeah, time series demo, the idea is I could put a bunch of data in here. Here's one time series and here's another, and I can add these. So if I create the sum of these 2 time series here, we'll see their years don't quite line up. This is from 92 to 96. This is from 91 to 93. Nonetheless, the sum should work, and it should combine the data in the most natural way, which is to assume that one of them has no data, or a 0 value in years that are missing. So we'll treat this one like it had 0 in 1991. Now we'll also have a division class, method, divided by method, where I could take one time series and divide it by another. So if I take this series and divide it by this one, well, it's okay because every one of these numbers here, you'll notice this is a time series of integers, by the way, and this one's of doubles. We could divide these numbers and get natural results, right? So I could take this one and divide it by this. Now, if instead I tried to divide TS by TS2, that would be a problem because there is no 1995 or 1996 or 1994 value for that matter, and it would cause an illegal argument exception. Okay. Now, the only thing that matters, right, as far as it being an allowable division, is whether or not this class right here, the one that's in the bottom of our division, has all the years at the top. So we don't care if it has extra. That'll be okay, though we won't test it. So it's kind of undefined behavior. But in case you want to know what's the best practice, I don't know. That's just my sense of how it would work. Now, the other thing is the interesting thing about years and data. So it seems annoying, and it will be annoying when you try it. So the question is, why are we doing this funny thing of returning a collection of numbers instead of returning like I don't know, an array of somethings, or even just a collection of whatever my type is. And the reason is that our plotting library that we use, it requires collections of numbers. So we'll do that. And in fact, that's one of the main inspirations for this class's existence, is the ability to conveniently make collections of numbers. Okay. So some important questions come up, which is, what exactly is a collection of numbers? Is it like an array list? Like, I don't quite get it, you might say. Okay, well, the point here is that we don't know what kind of collection we're going to get. It could be an array list or a set or who knows what. But as long as it's some kind of valid collection, I mean, we have a bunch of collections we know about. As long as it's a valid collection, it's fine. We just get like a collection of numbers. Okay, so as an example, if we look in a time series demo, there's a point where I create a time series, and I ask for a collection of numbers that I'll happen to call years, another one called data. Okay, so I have some kind of collection. I don't know what it is, array list, list, set, it's something, but I don't care. All collections can be iterated through. So if I go through, for example, and I say, hey, go through every year number in years, get the corresponding value, and print it out, and we run this code. So this is the demo. You run it on the solution. I mean, you won't be able to do this yet. But what we'll see is that in the year 1992, the values are all these things, right? So all these 5 lines is this code right here running, okay? So what your years method then does is just returns those years in some kind of iterable collection. Okay, now I actually have added a new thing compared to if you pulled the skeleton before. So there's a new thing in time series demo I made watching or doing this video that became apparent to me, which is that we also need to be careful about the order that we return data, okay? So notice that we have years and data. So data needs to return all data for the time series in the same order as years. So in other words, if we run through and we iterate through the data and just print out the values, okay, so we get each number. A number isn't something we can necessarily, so we get some number, we happen to know it's a double, so we'll convert it to a double, and we'll say that in some year, the value was something, right? So it's important that this collection here, if you iterate through it, that the data comes out in the same order. Otherwise, your plots will look wrong, okay? So we do see that happening here. So we iterate through data, and we see that the first number that comes out is 3.6, then 9.2, then 15.2, and so forth. Just like before when each year came out one by one, right? So this is probably one of the trickier concepts in the whole project. I hope it's not too annoying. Please seek help if you're confused. Okay. Now, that said, your code's ultimately going to need to return a collection of numbers. Okay, so how do you do that? Well, one issue that you're going to have to contend with is that you would maybe even be able to just like maybe get around, well, no, okay, I'm not going to go there. So if you want to make a collection of number, all you need to do is make like an array list of number or a set of number or whatever, because an array list and a set and so forth of numbers is a collection of number. Now just be warned that if you try and do something, let's say in your code, you try and say, you're writing your years method. I don't know, let's open up method signatures real quick. Student method signatures. Okay, so I try and write years, and I do like array list of integer, x equals new array list, integer, blah, blah, blah. This won't work because of the fact that in Java, a collection of doubles is not a collection of number, all right? So in other words, if I tried to return x after doing a bunch of work, well, an array list of integers is not a collection a collection of number, right? Because these don't match. This doesn't get automatically changed, basically. It's just not a thing that happens in Java. Though I will note that an array list of number, that is a collection of number, okay? So subtle distinction, I don't know. Maybe some of you guys already don't find this so crazy. I don't know, but it seems like a thing that you guys might get hung up on. So I hope that helps. But yeah, that's probably one of the very trickiest things. But I think it'll be a really good lesson, because if you really get that, then you really get generics in Java. Okay, so onwards, we have yearly record now. So if you finish time series and you finished WordNet, yearly record is the last thing you need to finish in order to get the magic, glorious bonus point. All right. So yearly record is going to be harder to design, but it's going to have a little less craziness when it comes to the generic stuff, okay? Or at least you will have already seen it. So let's consider what we have here, right? So the spec and the Java docs lay out a little bit more about the yearly record class, but you might find the demo also very helpful. So a yearly record specifically represents what it means. It's in a particular year, it's the counts of all words. So this yearly record represents the counts in some unknown year. The yearly record doesn't know what year it's from. That's someone else's job. So this yearly record, we put in Quayside and say 95, Surrogate 340, Merchantment 181. In other words, these are the counts of each of these words in whatever year this yearly record corresponds to. Now there's some natural questions you can ask, like how many words are there in the yearly record? How often did a particular word count? Or did a particular word appear? But perhaps most interestingly, there is the notion of the rank of a word. So the most popular word is going to be rank 1, and the least popular word will be rank n, where n is the number of items. Okay, and so there's various other examples here that I'll let you peruse, but I'll just focus on what I think is slightly trickier about this. Okay, actually, I should mention first that before you really dig into yearly record and start writing a ton of code, it's probably a really good idea to think about what your design is going to be. And in particular, I urge you to look at a vaguely similar thing in the discussion worksheet called the bi-divider map. Okay, so particularly this problem. Now, it's not quite the same thing, but if you understand this and you understand the solution, then I think you're really well primed for this. I would recommend not trying to do yearly record until you look at this and you look at the solution and you say, okay, yeah, that makes a lot of sense, right? So if this all makes sense, you're in great shape. Okay, so there's some performance requirements for yearly record, which is that assuming that you're not going to call put anymore, and we're just going to ask for the rank of words, the size of the entire data set, and the count of things, your code needs to be so fast, BB, so fast. Let's fix that. All right. So it must be so fast that they are effectively independent of the size of the data set. Okay, and you can assume throughout that all of the map classes are very fast, so that's okay. And if you look in the spec, we have a name for this. So if we have a yearly record, which we have nothing else to put into it, we'll say that the yearly record is now frozen. Now it's not like you can actually say like freeze this yearly record and then it's frozen, but that's just my word for it. So if you have a yearly record, you know you'll never put something in again. We'll call it frozen. And it's under those circumstances, these methods should be really fast. Okay, and we'll formalize all this. And if we'd already done asymptotics, this spec would be much cleaner and mathier. That's it. I actually added another performance requirement, is that put should also be independent of data set size. But the problem was that some of you guys had already finished a lot of the project. So that seemed mean. So instead, I made it bonus points to meet this. Though I will say that if your put method takes a long time, then it means that whenever you try and make plots, they won't be as cool. All right, because you won't be able to load the big file. You won't be able to make these plots here because putting all this data is going to take too long. All right. Okay. So one way of putting it, because I know these performance requirements are a little confusing, and if you're somebody learning about the spec for the first time, by the way, I would consider pausing the video, going and doing a bunch of work, and then coming back when you're ready to do yearly record, because I don't know, it just seems like it's going to get crazy. But you're welcome to keep watching. I mean, I can't stop you. I'm just a robot on the internet. I mean, not me, but the version you're watching. So let's suppose we create a yearly record called x1, and we call x1.put 1,000 times, and then call x1.rank, size, and count 1,000,000 times each. Okay. Now let's suppose we make another yearly record called x2, and this time we put in 1,000,000 things in this yearly record, and then we call rank, size, and count. All right. So all those performance requirements, another way of putting it, is that every call to x1 put and x2 put should take around the same amount of time. So it's not like it should start crawling to a halt. I don't know what I was trying to say. Anyway, it shouldn't get really slow when you get up to really big x2s, right? And additionally, and this is the bonus extra credit part, but the one you definitely need to make sure you do, because it's been in the spec longer, even though I think it's less important, is that on average, every call to rank, size, and count for either of these data structures should be really quick. So even though this yearly record is a lot bigger than this one, it should be about as fast to call rank, size, and count. Okay? Now it may be the case that, I don't know, one of your particular calls is a lot slower than the other, but on average, they should take around the same time. And hint, hint, the bi-divider map that we just talked about, where'd it go, is a good example of that idea, all right? So think about this one a little bit. Okay. So you can assume while writing this that all map operations are very fast, but you should not assume that list operations are fast, okay? And we're being a little hazy now just because we haven't learned a lot of stuff about runtimes, but in Project 3, we're going to see a lot more. Okay. So general tips. Again, make sure you see the demo files in order to disambiguate. I hope they're sufficient. And again, when it comes to dealing with generics, I want you guys to make sure that you don't spin your wheels trying to find where to move your K's or your V's or whatever it is you're trying to do. Please seek help because it's not worth your time to just get stuck on some syntax issue. And I will be updating the slides with common issues as we go. And yeah, one particular thing, if you haven't done it yet, that I mentioned earlier, was the notion of the Lecture 14 hard mode, which covers a lot of these corner cases. I'm assuming if you're watching this, you've already finished homework 5. So I guess homework 5 is another thing you should make sure to do. So once you finish time series and yearly record in WordNet, you're actually very far along in the project. You all have Ngram map, which I think should be fairly straightforward, and I described it a little earlier. And then we'll come to the ancillary pieces of the project, the things we need in order to make it cool. Okay? So the harder of those is Plotter. And the Plotter library is just something that's going to make it easy to make visualizations from Ngram maps. I'd recommend, if you have the time and the inclination, try and figure out how to do Plotter on your own, because learning how to go through and look at a library, that is to go to the website for XChart and look through the examples and other code out there, it's a very valuable thing to be able to learn how a library works. So I think this is a good opportunity, but given the fact that I don't want this class to eat your entire life, there's a big hint here that will help you a lot. Okay? And don't worry too much about matching what our plots look like exactly. In fact, ours are kind of sub-ideal. If you'll notice, like, my years have commas. Okay? You can fix that if you want. Don't fret. You don't have to match this formatting exactly. It's not the point. Oh, and by the way, one thing I guess I should mention, which is a little silly. If I try and quit right now, because of the way that the Java Swing API works, it won't quit until these are closed. And even weirder, if I close one of those, it will actually kill my program. So don't try and fix that, right? The UE is secondary to the rest of it. You can spend the time. It's not so hard to fix these bugs, but they're not required, and I didn't even bother in the reference solution. Okay. So after you've got Plotter done, or use this big hint, if you go to, the next thing you'll do is write the actual user interface, which will involve learning how to read what a user is typing and respond in some nice way. All right. So the first step that you'll want to do is make sure that our provided NordNet NUI, this thing right here, so you'll want to rename this as NordNet UI. I don't really have a good way of saying it. I don't know how you've been saying it. Best, let me know in class. But yeah, NordNet UI. Make sure that this thing, whenever you've renamed it nordnet.java, that it compiles and runs, and that these things are appropriately set up. And then you should go to the demos and look at this example UI file, which I think you're welcome to copy and paste this directly and work from here. I think you may find it really helpful. And I don't think this will be so crazy. Ours is only 68 lines. I think you'll find it interesting, but let me know if it's terrible. Okay? And then there's the icing on the cake. So we'll add a few more commands, and this is mostly to inspire you. Maybe not now in the middle of the semester, but maybe later you can, I don't know, or now, you can build out our UI to do something really cool. Because now we've done something that is not possible, that it was not possible to do with just the plain old Google Books data set. There are things actually, once you get to this point, you can ask that you cannot do in the Google browser, right? In Google, you can't say, give me all of the subwords of dog, because it does not know about the idea, right? Like if I say dog here, I'm just getting literally the word dog. There's no corgi or anything like that, right? So we, using the WordNet database, now can answer more interesting questions than you can here, maybe. All right? So another type of thing you might try and do is start looking at aggregate data. Instead of only looking at the history of words, I want to look at the history of all words, like maybe the lengths of words. So this part of the assignment, I think it'll be fairly straightforward. So you will write one yearly record processor that, given a yearly record, it gives you a double, all right? And the one you're going to write is called word length processor. So moves. Let's suppose that we're back in this ancient times, 15,000 BC, before the written word was popular. Somehow there are printed books that said it rained and it rained again, and we're using an alphabet even though this is all we're writing. I don't know, it's kind of fantastical. Well, in that case, if we looked at these texts, then we'd say that the average word length that year was 2 plus 2 plus 6 plus 6 plus 5 divided by the number of words, and that would give me an aggregate sense. So there's these kind of competing theories about society. One of them is the what's it called? The Flynn effect? Floyd effect? Flynn effect. The Flynn effect is the substantial and long-sustained increase in smartness, right? So you might think, aren't words getting longer, perhaps, in written things? But then there's also the idiocracy approach, which is the idea that over time, well, it's not as succinct, but that the human race is getting worse as people get dumber. You get, I don't know if you've ever seen it. It was the first movie whose set I ever went on, actually. This took a long time to come out. But yeah, when I lived in Austin, my girlfriend at the time worked on this film. We got to crawl through piles of trash. It was cool. Anyway, so you might think, maybe the whole world's getting dumber and the Flynn effect is wrong. So one way to settle this, possibly, is to look how long the words are that people are writing, and this will let you try that out. And then lastly, the somewhat mysterious Zipf's law, all right? So in this final part of the assignment, what you'll do is add a new command to Nordnet UI. If you want to, you can write the plotter function to learn how to do a log-log plot, and we'll also now take, finally, our ranks and make them useful. And at that point, you'll be able to plot Zipf's law, all right? And what you'll find, and I guess maybe if I still, it's not still up, but the surprising fact is that there's just no reason that if I plot the count of a word versus its rank, like the rank is just something we made up. I mean, like the number 1 ranked word appeared 1,000,000 times, whatever. But what's crazy is that Zipf's law, what you'll see is that the number 2 word, supposing the number 1 word has 1,000,000 instances, the number 2 will be like 500,000. And the number 3 word will be like 333,000, and then 250,000. And this plot will show that it actually holds across data from every year, all that kind of stuff. And it's just completely insane to me that this is true. I don't know, it's just so bizarre, right? That like the number 5 word should occur 1/5 as often as the most popular word. That's ridiculous. And nobody knows why it's true. And this comes up in all kinds of other fields other than this. Perhaps evidence the universe is a simulation. Anyway, well, feel free to add other things after that. And I ask that you guys post whatever you learn on Piazza. And I'll post a link here for us to share. But I don't want to, for example, spoil the answer to this. Okay, so I hope that video was useful and not too long and boring. And I will see you guys in the near future.